to improve the performance of the computer systems. And for that, we need to understand the very basic computer architecture, that what a computer is, how it is designed. And the basic design, we have two kind of architecture. One is hardware architecture and another is von Neumann architecture. And the von Neumann architecture was proposed during 1940s by a mathematician called John von Neumann. So basic difference in the both architectures, pictorially if you find the difference, that only difference is in case of memory. In case of hardware architecture, we have two different memory, one for the instruction itself, another for the data memory, but the data will get stored. But in case of von Neumann architecture, there you have only one memory where both the instructions and the data will reside together. And the basic component of the systems are processor, memory, and the data path altogether. And input-output system are very much insignificant for us when we are talking about high-performance computing, because this input and output depends on the human effort, how fast you can use the computer. But we are desperately wanting, or we desire that the computational power means nothing that you are reading some data, not that how fast you are displaying on the monitor or screen, but how fast you can do large number of computations. Because input will be taken once or twice, output will be produced once or twice, but you require lot many logic and arithmetic computation to be done to come to a conclusion, and based on that conclusion you will give some output. So our main focus will be to improve the computational speed. So here the three main things that plays the role is processor, means what we call the CPU, memory, and the bus system through which the data travels from one part to another of the system. So hardware architecture is very little interest, because nowadays this kind of architecture are not followed. All the computers that we are having nowadays even are based on the architecture, von Neumann architecture proposed even during 1940s. Still we are having that. So the performance depends on how fast we can fetch the instructions that will be done by the CPU, how the data supply to be increased, that for that responsible is your memory, so we have to speed up the memory, and the processing power doing some calculation, arithmetic or logic operations, we need to speed up the CPU, and for the data movements we require to improve the bus system or data lines or control lines, whatever. So these are the scope area where we can do something so that we can increase the performance, because these are the primary component of any systems. So how to improve this performance? We have two approaches. One is hardware-based approach, that from hardware point of view, what we can do to improve the performance. Another is from algorithmic point of view, that we call like it's a set of hardware and software. So from algorithmic approach, we have to give some alternative solution to the problem, while using the different improvement in the hardware sectors, so that we can utilize this hardware for solving the problem. So we have to rethink about the solution strategy, as well as we have to improve the computational power if we want to improve the performance of the system. So from hardware-based approach, what we can do in case of hardware, we can either improve the technology, or we can improve the architecture of the computers, or we can apply some kind of parallelism at hardware level. We will see all this gradually. So in case of hardware improvements, generally this role is played by the Department of Electronics, and mostly now digital electronics. Analog is gone, and semiconductor industry. So successful research in the field of electronics and digital electronics and semiconductor technology, what we have done is, earlier we used to have the ICs at a very larger size, and nowadays, due to the development in the semiconductor industry, all the components has become very small. And what is the result of this? Within the same area, now we can put lot many logic circuits all together. So the transistor density per unit area has increased drastically, and much more number of such transistors means large number of logic circuits you can embed, and that will faster the processing capability of the circuit, maybe in redundant mode, or maybe in some other logics that we'll go through. So we have gone to higher level of integration in the circuits. So from vacuum tube, we have moved to transistors, and from transistors, we have moved to ICs, from there to small scale integration, from there LSI, from there MSI, then VLSI. Now we are in the era of system on chip. So chip technology is nowadays so advanced that we are about to close in 1 billion transistors on a single chip nowadays. So earlier the size of a transistor is now the size of a processor nowadays. So because of this higher level of integrations, we can make the circuits in a compact way with lot many circuits together to be used for purposefully to improve the performances. So this transistor per processor transistor allotment or transistor count, you can follow up that year wise. Whenever the new processors are coming and the number of transistors employed and the area remains constant, almost. So much more number of transistors we are now able to put within the same circuit. And we have to utilize these transistors purposefully to improve the performances. Second improvement is we can do in case of improving the clock frequency of the processor itself. So if we just statistically go, the first processor that was proposed by or launched by Intel was 4044, that has only 470 kilohertz of frequency. From there, if we have moved up to Pentium 4, which has 3.4 gigahertz approximately stable clock frequency. Now, more the clock frequency means, if you consider at each and every frequency we can do one operation, then much more frequency is within the same amount of time we can do much more number of operations. That may be per second, that may be per microsecond, whatever the time unit is. So when we improve the clock frequency, then we can assume that per unit time duration we can complete one operation. So much more frequencies means much more number of operations we can complete within the same amount of time. So gradually you can follow up that the frequency from some kilohertz to some gigahertz we have gone through. So huge drastic improvement in the clock frequency rate. And we can check out the frequency, how they have increased. So on an average, 30% clock frequency is increased per year, at least up to 2010. So that is one reason that we are having now faster processor. But what happened suddenly during 2010, that the clock frequency improvement is almost stagnant. There is no further improvement in the field of clock frequency increase. Stable one, 3.6, some processors, but those are not very much stable one. But beyond 3. But stable one is 3.4 gigahertz that we get generally, lower than that even. But what happens suddenly that there is no further increase in the clock frequency of the processors. So the problem is, when we try to improve the clock frequency further beyond 3.4 gigahertz, it produces so heat the processor itself gets burned. So we are now stuck to the heat wall that we cannot go further in this direction, that we will keep on increasing the clock frequencies. So we are stagnant up to 3.4 gigahertz in that respect, from the point of view that will improve the clock frequencies, through which we will be improving the processor speed. Now what can be done? And you can just have it for your idea, you can check out that what is the level of heat produced by any processor. Any Pentium processor produces heat nearby about a hot plate. And if we try to improve further, then it will go near about to a nuclear reactor. Beyond that, rocket nozzle or something like that. So after 3.4 gigahertz, we are stopped that in this direction we cannot increase further because heat will be the problem. So now from there you can understand why the AC is there in the ATM. It's not to give you a comfortness, but it's for the computer that is installed in the ATM machine so that it can run for a long time without stop. Now, what to do now? Is there an alternative way to speed up the processor?